Welcome to the Engineering with Nature podcast. The U.S. Army Corps of Engineers has been working on the Engineering with Nature initiative since 2010, working and collaborating to advance the use of natural processes and systems to deliver a broad range of economic, environmental, and social benefits. EWN develops and implements nature-based solutions for water and infrastructure projects. It brings together a growing international community of practitioners, scientists, engineers, and researchers to harness the power of nature to innovate and solve problems and create sustainable solutions. This podcast tells their stories. Now here's your host, Sarah Thorne of Decision Partners.
Imagine if scientists and engineers put their heads together to figure out how to use 3D printing to create nature-inspired infrastructure. What would they create, and how might those new materials be used? That's the focus of our discussion today. Welcome to Season 5, Episode 1. My Engineering with Nature co-host, Burton Sudell, is a research biologist in the Environmental Lab at ERDC, the U.S. Army Corps of Engineers Engineering Research Development Center. We're thrilled to be joined by two of Burton's colleagues, Al Kennedy, who's a research biologist, toxicologist, and macromolecular scientist. Al works in the risk branch of the Environmental Lab. And we have Zach McClelland, who's a mechanical engineer who works in the concrete materials branch of the Geotechnical Structures Lab. Hey, Burton, over to you.
Hi, Sarah. I'm delighted today to have Al and Zach with us to share what we have been collectively thinking about and what we've started to collaborate on with our colleagues across the ERDC labs, as well as with our external partners. I think the potential for designing nature-based solutions using 3D printing is a very exciting opportunity for us to pursue from a research and development perspective through the Engineer with Nature program funding.
Indeed. Welcome, Al.
Thanks, Sarah and Burton. I appreciate you inviting me to the EWN podcast. I'm excited to have the opportunity to discuss our concept of bringing subject matter experts together from the diverse fields of biology, engineering, architecture, materials science, social science, economics, and advanced manufacturing. As mentioned, I'm a research biologist. I was hired at ERDC about a decade and a half ago with a focus on ecotoxicology, but my interest expanded dramatically. Got into material science through looking at the safety of engineered nanoparticles on the military side, and got involved in polymer science through long-term training opportunities with Virginia Tech. I'm looking forward to discussing 3D printing nature-inspired infrastructure, or NNI, but more on that later.
Great. Thanks very much. And Zach, how about you? Welcome to the show.
Hi, everyone. I appreciate the opportunity to discuss some of the fun areas of additive manufacturing with you today. So additive is a great area for bringing together researchers and scientists from all sorts of backgrounds. I'm excited that it's starting to reach into the engineering with nature side of things. So a little bit about my background. I started in AM with your typical small but high resolution prints that most think of when you think of additive manufacturing. And from there, I really moved into large scale structural AM. So getting away from things that are inches or measured in inches and moving to things that are measured in feet. I lead a team ranging from mechanical engineering to civil engineering, even polymer scientists and material scientists as well. So I'm excited to talk to y'all today about what all these backgrounds do and why they're important for the space of additive manufacturing, and specifically in this application.
Awesome. Thanks, Zach. AM, I learned something new today. Additive manufacturing. Good stuff. Okay, so let's set the stage here. First, we want to talk about what we really mean by nature-inspired design using natural materials. So this is very much a principle of engineering with nature. Burton, maybe you could lead us off.
Sure thing, Sarah. When we think about conventional or gray infrastructure, it's usually built out of concrete, steel, or large rocks. But when we do that, it is often in conflict with natural environments. The primary reason for that is if we're just focusing on the engineering solution, we are not considering then the other potential benefits that could be associated and designed into that project, including social, economic, and environmental benefits. So far, here at the Engineer Research and Development Center, we have the opportunity to build capability in additive manufacturing field. We can build on past successes by investigators outside of the Army Corps of Engineers and take it to the next level, particularly from the perspective of upscaling. We want to go beyond the pilot, the demonstration scale, because if we can upscale these types of projects, that will lead to greater successes over wider areas of the environment. So Al, how do you see the opportunity to use nature-inspired solutions versus conventional approaches?
Well, first, traditional manufacturing in its most basic sense generates simple block-like structures that don't mimic nature. For instance, traditional injection molding of polymers or plastics requires use of an expensive metal mold to form shapes. While that's highly efficient for making large quantities of the same part, you are stuck with that same shape until you get another mold. Additive manufacturing, or more commonly known as 3D printing, offers opportunities to get out of that mold, where additive manufacturing is called that because it creates objects layer by layer through computer-aided design, while subtractive manufacturing or traditional manufacturing starts with something larger and chips away at it. So what I think is 3D printing unlocks the ability to make complex, overlapping, nature-inspired geometries that are impossible by traditional molding methods. This includes nature mimicking asymmetric structures such as mangrove roots or coral-like substrate that can provide habitat enhancements and erosion controls, all while being aesthetically pleasing in recreational areas. There's also an opportunity to blend and composite synthetic and natural biopolymers. This allows scientists to tune the material's structure and mechanical properties, as well as its surface chemistry and porosity, for whatever the site-specific need or application may be, such as promoting organism colonization or, conversely, anti-fouling self-decontaminating surfaces. There are also natural composite filler materials that can be added to our feedstocks we use to 3D print habitat, for applications such as carbon or contaminant capture and nutrient sequestration.
So it sounds like there's all sorts of possibilities in 3D printing. Zach, I want to talk to you because you've been working in the concrete materials branch at GSL, and let's face it, concrete's a pretty traditional material. What's your perspective on all this?
You're right. Concrete is a pretty traditional material. It's actually the most widely used construction material in the world and has been around thousands of years in one form or another. A lot of what the branch I work in does is focused on the development of new concrete mixes. We actually hold a patent for what we call ultra high performance concrete that has a strength of roughly 35 KSI. Now, to put that in perspective, your typical concrete used for, say, like a driveway or something of that nature is on the order of 3 to 4 KSI. So a huge difference in your mechanical strength that you get from that. We also specialize in mixed designs using what we call indigenous materials. So all that is basically using locally sourced material systems at locations across the globe to create a mix with similar properties to what we would see here stateside, created in the lab using materials that are locally available here. So the beauty of all this research we have done on concrete or cementitious materials is now we can leverage it for many of the EWN applications or projects that have demonstrated the opportunity to incorporate natural-based features into conventional infrastructure solutions. So now we can take that to the next level and use 3D printing. Some of these materials, like concretes or biopolymers, can now be given more complex geometries, kind of as Al mentioned there, one of the big benefits of additive, through the use of some of this 3D printing technologies. Really opening up the potential applications of these materials like we are seeing here, with the potential for ecosystem restoration or coastal surge and flood risk, where you don't have to have maybe a big, ugly seawall or something like that. I was in a meeting recently where they described some of those seawalls as post-apocalyptic walls, because a lot of times they're all graffitied up and covered in paint or something of that nature, and they're just big eyesores. The beauty of additive, though, is you're not necessarily limited to these. So you can also focus on design for the sake of design and what its function is supposed to be, but you can also think about the aesthetics of it as well. So really kind of using additive to create structures that serve multiple purposes now, through whether that's creating molds or actually fabricating the part directly. For an example, there's I want to say it was a children's museum that was recently made, I think it was in Memphis, Tennessee area. They used additive manufacturing to create molds, but then used traditional manufacturing techniques to actually fabricate the structure. So they made these molds out of different planets and shapes and things of that nature, and then used traditional concrete forming to actually make this structure. So they ended up making a building with exterior that was made, that couldn't have been made without the use of additive manufacturing. So leveraging a lot of those techniques for all sorts of different applications to increase both aesthetics and functionality, and really starting to see a paradigm shift in what you can do with the technology compared to traditional, as you say, concrete materials and such.
That sounds pretty cool. So let's go on and let's talk about, how did the three of you come together and start thinking about this opportunity for 3D printing?
Well, Sarah, I think I can address that first. I believe we initially started working in our respective labs, thinking about our own projects in mission space. For example, in the environmental lab, you may wonder why we got into 3D printing. And we were initially focused on the implications of 3D printing, like energy use or emissions. But honestly, the applications of 3D printing, and specifically the environmental applications, became much more interesting to us. This includes absorption of contaminants that are coming out of dredged material, either to detect them or to remediate them, and also destruction of contaminants that come out of dredged material, or even control of harmful algal blooms and the toxins that the algal blooms release, using some additives we can put into 3D printed structures. But from my standpoint, I began to learn more and more about the 3D printing capability and subject matter expertise in GSL and Searle to make 3D printed objects stronger and better. As far as how this project idea materialized, I'm not entirely sure. It wasn't a forced idea, just a natural evolution of thinking from our interactions, part of the synergies inherent to the ERDC culture that make us better together.
Working back and forth across the labs. I want to talk about what's really an emerging technology and really a new way of thinking about materials and the need for sustainable solutions. And Al, maybe you could start and talk a bit about, why are you collaborating on these emerging materials now? Why this emerging materials technology focus? Why now, and what's the driver?
I guess there's just so many problems that we need to innovate with outside the box solutions. I mean, this includes climate change impacts related to coastal surge and flood risk, and many opportunities for using these novel materials in nature-inspired infrastructure for ecosystem restoration. Really, the best way to define this is a convergence of multiple conventional and emerging technologies into a novel synergistic capability. So you ask why now? That's a great question I hadn't really thought much about before. The concepts just seemed to come together as we interacted. It may be related to the reduced costs and improved user friendliness of the 3D printing equipment. It relates to recent capital investments that we've made at all three ERDC labs that are involved in this project, and the commercial availability of novel 3D printing technologies. So technologies that can use natural materials such as sand and clay, and that made potential beneficial use of dredge material as a feedstock for 3D printing seem somewhat obvious. And as an ecotoxicologist, I'm into sustainable materials, so we have to make sure that these materials work in the environment for, animals so that they can live with them.
So the timing is important. The timing is now. Zach, give us some practical benefits of 3D printing and what you guys are envisioning with this technology?
Yeah, so the great thing about additive manufacturing or 3D printing, whatever you want to call it, is the ability to create complex geometries. It's really what it boils down to. So you're either unable to create through traditional means or are not very cost effective. A lot of times is a big driver for that. So for example, like I mentioned before, you could use some form work to create potential habitats or nature-inspired designs. But you would have to make those new forms each time. Or if you have a new design, you'd have to create a new form for that. Through additive, you completely eliminate those forms. You can do it all directly from the 3D printer. So it really opens up what is possible in design. And another kind of going back to the why now, I always kind of, when I'm explaining additive or 3D printing to people, it's kind of like a computer. By the time you go online, you order a computer and you get it in-house, it's probably obsolete and there's something newer and better out there. There's something that runs faster. Additive right now, there's a huge push in this research area. So it's very similar. So by the time you get a printer set up and you get to using it, there's already some new technology out there. There's new material systems that can be used. Us on the material science side are always trying to develop new materials to do particular applications.
Okay, so let's pick up here and let me ask you, is anybody else doing this kind of 3D printing now?
Well, Sarah, I suppose that depends on how we define this kind. There's obviously, listen to Zach, lots of companies and universities and agencies and even hobbyists designing and 3D printing novel ideas. Less are looking into natural structures, and much of that work is overseas. There's efforts like the Reef Design Lab and Living Seawalls Project, and D-Shape, an Italian company, is among the first to show that larger scale printing of corals could be possible. But bringing this to an Army Corps infrastructure context is completely unique. And there's just not many, if anyone, thinking about printing dredge material as a beneficial use, using natural materials to make natural infrastructure. Bringing this to the engineering with nature community practice will dramatically expand brainstorming of new ideas for 3D printing of natural inspired infrastructure, revealing opportunities and site-specific needs we haven't even imagined yet.
It really fits with the whole concept of engineering of nature and the application of natural and nature-based solutions. So a key theme that you've touched on, but I think we should talk a little bit about, is the need and the opportunity for multi-lab and multidisciplinary collaboration. Let's explore that for a minute. Why is it so important now?
Well, my first thought is working within your expertise provides a certain level of comfort. It's streamlined and efficient, but it's definitely more narrowing, and it was just time to get uncomfortable. Some of us know habitat requirements, some of us know materials and processing, some of us know coastal resilience and hydrodynamic modeling, and we just had to come together.
Talk a little bit about the role of the different labs, can you, Zach?
Yeah, definitely. So I'm a weird duck there. I actually enjoy the uncomfortable. I'm your stereotypical ADHD engineer. So I love doing a bunch of different things all at once and learning new areas of interest. So additive is perfect for that. Across the different labs here at ERDC, everybody has kind of their own unique niches and areas that they work at. So environmental lab, like with Al and his group, you're looking at natural design or use of natural materials and ecotoxicology testing to use biocompatible materials and things. We also work with our coastal hydraulics lab. So they're going to be more looking at iterative hydrodynamic modeling of some of the prototype structures that we'd go through. So how are these different geometries going to affect shoreline and wave breaks and things like that. Our construction engineering research lab is actually one of the foremost leaders in concrete 3D printing. Most of what their work portfolio looks like is more on the structure side of things, so buildings and such. But utilizing a lot of those lessons learned and technologies that they're developing on that side of the house for a lot of our applications here on the EWN side is definitely critical. And then GSL, Geotechnical and Structures Lab, where I'm located, we're more going to be focused on our mechanical engineering, resilience of materials. We do a lot of large scale 3D printing for structural components for like infrastructure. So waterways navigation and things like that. So trying to take a traditional printing system that would, like I said earlier, inches, and moving it up to something that you could make for like several feet, all using additive technology. And we also, the other hat we wear is a lot of materials focused. So really looking into either development of new material systems or better understanding the material systems we have, and working in partnership with Al and the EL group to understand how these, when we move them from some of the applications that we would typically use for like structures and things of that nature, how they're going to affect the environment, and moving forward with some of those particular applications.
So it's really critical that you're working across the labs, that you're collaborating together, and that everybody's getting a little uncomfortable, to Al's point, and having to think outside the box. I think that's really cool. So you guys, let's talk about what's ahead. You're just at the very initial stages of a project, which is going to entail working across the ERDC labs on 3D printing natural materials that you believe are going to unlock complex nature-based infrastructure solutions. And Al, I understand you're the principal investigator. You're working with Burton and Zach, along with Mark Ballantyne and Andrew McQueen from the Environmental Lab, and Gaurav Savant from the Coastal and Hydraulics Lab. Can you tell us a little bit about the project?
We're planning to kick off the project in the spring to fall 2023 timeline, and we'll kick that off with a workshop forming a diverse community of practice. So we call the project Removing Artificial from Artificial Habitats, 3D printed natural materials to unlock complex nature-inspired infrastructure. The problem we try to address, as stated, is that traditional manufacturing materials used for infrastructure just lack natural complexity. And you can take cement, which is a bit alkaline in pH and might not be super attractive for organisms to colonize. The infrastructure could focus more on, natural aesthetics rather than only engineering functionality. We want to go from geometrically simple shapes to something more complex. And in traditional manufacturing, it's just a lot more difficult to prototype something like a natural structure. With additive, we can prototype it on the small scale, and then once we're happy, we can start making it larger, using some of the technologies that Zach speaks about.
And talk a little bit about what you hope to achieve with this project.
Well, the solution that we hope to arrive at this project is to mimic natural inspired infrastructure using 3D printing. So our goals here are to leverage centuries of evolution for nature-inspired design, inform and engage stakeholders from the Army Corps, other federal agencies, academia, and the private sector, and really make additive manufacturing a mission enabler for novel solutions. The benefits, I mentioned the beneficial use of dredge material as feedstocks. Mobile capability, we could actually print this in the field with some technologies that Zach has. It's mobile. And the opportunities to establish these interagency partnerships to realize the full benefit of nature-inspired design across agencies, not just what we've thought about so far. That's the point of some of the early on workshops. And we want to demo the use of these natural materials. They're not as easy to print as the commercially available things, but we want to get there. We want to make natural materials standard so that it's used at EWN proving grounds.
I think it's a fantastic project, Zach. The big question is, why now for this project?
So, kind of like I said, definitely additive manufacturing is a huge push right now. It really gives us that extra control in geometries we can produce in a wide range of scales. So a lot of the technologies we're looking at for this are anywhere from fused filament fabrication or robocasting or direct ink write, as well as binder jetting. So these are all different additive manufacturing processes. So they do different things, whether you're extruding a little polymer strand outside of an extruder, or you're using some kind of almost think of it as a spray-on adhesive that's basically being applied to certain locations that's then creating your part. But all of these have different capabilities and material systems that can be used and such. And so a lot of that research has been done recently to really start to understand those different technologies and such, and then really get into the material systems. So additive also offers a wide range of natural material systems that we can use. So anywhere from polylactic acid or PLA, which is a biopolymer, to composite systems that may be a PLA matrix but contains varying amounts of, say, natural materials like clay. So in binder jetting processes, we can also utilize materials like sand and gravel, as well as clay to print. So really, you have a wide range of options that weren't necessarily there in the past for some of these kind of engineering with nature applications. So a lot of times in the past, you may have some kind of toxic material system or something like that that wouldn't exactly lend itself well for this. But now you're starting to use more natural materials for a lot of these applications that kind of really started to open the door a good bit.
Burton, I think this project has the potential to take engineering with nature and nature-based solutions to the next level. What do you think?
I think we need to get beyond the pilot and demonstration scale, those small scale projects that we perform in the environment to help us understand how well the project is going to work, a proof of concept, if you will. We really need to get beyond that and to upscale these projects to really make a difference on a broader scale.
Yeah, it's just so important that we have a diverse project delivery team taking full advantage of the diversity offered at not only the ERDC, but beyond in the EWN community that's been built so impressively in recent years so that we can foster these ideas.
So the foundation is really collaboration, brilliant minds coming together from across the ERDC labs and beyond. And Zach, how do you think about this opportunity as an engineer?
I think it's great. So kind of as I mentioned before, additive, it takes backgrounds from everybody, from computer scientists to civil engineers, mechanical engineers, material scientists, all walks of engineering life, if you will. So for example, on the material side, you've got individuals, both civil engineers and material scientists, kind of looking at the rheology of different material systems and how that affects your print quality and getting a structure to actually even print and stay printed as opposed to just turning into a bunch of mush. And on the binder jetting side, you're talking about like polymer scientists creating new adhesives that are bio-friendly as opposed to some kind of volatile polymer system. So it really, I mean, on the CSE side or computer science engineers, they're helping with what we call slicers and actually being able to make the thing. So it doesn't do any good if we go out and create all these super complex materials for our application if we can't actually go through and make the tool pathing and such or hardware for other mechanical engineers. So it's one of those projects where it really takes everybody. It's a group collective. My background is nothing related to Al's. So when he and I started, it was kind of working on this environmental health and safety aspects of additive manufacturing. I didn't know anything about toxicology. I still don't know anything about toxicology, but we can work with his group and the people that do understand these things to solve these problems. And that's the beauty of additive is it's bringing all these different groups that are usually islands and kind of forcing them to work together to better understand the problem as a whole.
And you guys are looking to expand beyond just the ERDC labs. You're looking to really create a community of practice.
It's so critical to have this community of practice to unlock the full benefits of 3D printed nature-inspired designs. We have the foundation of what we think is an exciting disruptive technology that could change in how we do things in the nation's ports, harbors, EWN proving grounds, but we're just so very interested in learning from others to expand upon this through their thinking. There's implications to the quality and relevance of the results if we're the only ones working on it. There would be missed opportunities.
Let's move on and talk about how does the project get started and what are you hoping to accomplish in 2023?
We do have outreach opportunities and workshops in 2023. We do want to have our first workshop in the roughly fall of 2023, where we plan to discuss this capability and our ideas and then brainstorm with the community of practice to figure out what the future capabilities and opportunities that we could use on EWN Proving Grounds. There's a second workshop that we would plan for 2025, and that's where we would roadmap the feasibility of 3D printed nature-inspired design based on what we've learned from the community of practice over the 3-year course of this project, so that other folks within and outside the area can know when it's relevant for their site.
Zach, what about you? What do you hope to accomplish in the next year or so?
So I'm really hoping that with some of these like community practices and such, we start to kind of down select applications in specific areas that we want to start kind of using the technology. And from that, I'd really like to kind of take our group and start thinking about the material systems that are going to be needed to address these applications, as well as the hardware. So like I said before, I mean, there's a wide range of different technologies, even within just the additive or 3D printing space, that we can use. And so each one of them is different and has its pros and cons. Additive is not kind of the MacGyver screwdriver that one size fits all, if you will. So really kind of identifying which one of those components as a community that we want to potentially focus on, and kind of go from there. And then the other aspect for me for the next year is really kind of learning more about the EWN space. So my background, I'm on the other side of things. So whether it's structural or a lot of civil and military engineering type applications. So learning more about EWN and where some of the skill sets of the people that I work with could be better utilized is really what I'm going to spend in the next year doing.
Excellent. Hey, Burton, that's music to your ears. Talk a little bit about what you and the Engineering with Nature program hope to get out of this project in the next year or so.
Sarah, the Engineering with Nature program is going to get a tremendous amount of information out of this research. You know, the combining the laboratories and the geostructures and the environmental laboratories, it brings together disparate disciplines. And Zach was talking about not knowing much about environmental toxicology. And as an environmental toxicologist, I can say I don't know a whole lot about what Zach does during the day. And so that's very, very good. So we're going to learn a lot from each other. But the idea here is combining that knowledge is going to really essentially be additive. We're going to learn more from each other, and we're going to be able to accomplish more in this space. And I think from an Engineering with Nature perspective, there's a lot of applications for this type of research and this type of capability, whether we're below water, like say on the marine coast or on the freshwater coast in the Great Lakes, or applications could include even in our riverine systems. And then of course, the applications can be below water, could be at the water's surface with air, or it could be above water and provide benefits to those species that spend all their time above the water surface. So there's a tremendous amount of applicability for this type of capability going forward.
I'm excited. So I have to say, we wanted to kick off season 5 with a whiz bang technology, and you guys are really doing it. You're at the leading edge here. So thank you, Burton and Al and Zach. You've really given us a lot to think about the potential of this emerging new technology and what can be done as you explore the benefits of nature-inspired 3D printing with your colleagues. We really look forward to hearing how your project comes together and the opportunities and the applications you discover through your collaboration.
Yeah, thanks again for having me. I really appreciate the opportunity. Like most of your listeners, I'm new to the EWN space, so I'm excited to see how we can leverage additive manufacturing to kind of tackle some of these problems.
Great. Thanks, Zach.
And Sarah, from my perspective, I'd be thrilled to have the opportunity to come back in a year or two and to share with our listeners what we've learned and what we have accomplished in that period of time. So I'm sure it's going to be very fascinating, and we're going to be very productive, and look forward to sharing that with many others going forward.
That's great. Thanks, Burton. How about you, Al?
Sarah, I'd really appreciate the opportunity to do this and get the word out. Just to reiterate, we believe additive manufacturing or 3D printing is an expanding technology area for all sectors, with coordinated execution by a diverse multidisciplinary team. I think we'll start realizing that there's more and more capabilities. We need our researchers, site managers, environmental planners fully engaged to realize these benefits. Fresh ideas from diverse subject matter experts it's paramount. And I think the unique principles and synergistic collaborations available in the EWN community just provides the right conditions to achieve that. And I hope folks come to the first workshop. Thanks so much.
That sounds wonderful. Thanks to the three of you. We hope we can have you back on a future podcast to hear what you've been learning through your collaboration and where you hope to take 3D printing. And to all of you, thank you so much for listening. We hope that you've enjoyed this podcast, and we hope you'll join us again as we talk about engineering with nature.
The EWN podcast was developed by Sarah Thorne and Jeff King, Deputy National Lead, Engineering with Nature Initiative, U.S. Army Corps of Engineers. For more information, you can visit our website, engineeringwithnature.org. The EWN podcast is produced by iContact Productions for the Engineering with Nature program within the U.S. Army Corps of Engineers. I'm Dave Trafford.